Alright, so we're recording this one in advance this time. I'm learning. So, let's see. I was figuring that we would talk over problems 3 and 4 on homework 3. So, to get started, I thought that before we actually got into modeling, it would be handy to sort of talk about some of the write-up bit and also discuss what my plans are as we work through this. So one general piece of advice that I don't know if I've given out widely just yet is that when you're working on a SolidWorks model, it's usually recommended you spend a couple of minutes before you start modeling, just thinking over what you're going to be doing, what your steps are, and what what the important order is for features. So first up, reading over this, we are given a starter file, so make sure that we use it. I've got that open over here. We've got our unit set in millimeters. Double checking those. I was not so much of an ass that I would set the units wrong on you, but always important to double check. The material and part mass are given to allow us to double check our work, but the model is not graded on the mass. That is given for our use only. And also double checking material, cast alloy steel, cast alloy steel. So that's already set for us. Nice. We're going to be following good modeling practices, so don't calculate, skip, or repeat dimensions. And we're also going to make sure that we get all of our sketches fully defined with up to one exception, but that isn't really going to apply with this model. Um, we're only using material up to Lab 9 patterns, so we are not going to be creating any sweeps or lofts. And it is also recommended that we read problem 4 before we start modeling. So some of the changes that we can make some of the decisions that we can make while modeling problem 3 make problem 4 either easier or impossible. So good to keep an eye out for that so that we have minimal things that we need to change and fix at the end. We're also given hints. Most of the model is rotationally symmetric. Check both drawings to see what aspects can be done in the same feature and which must be done as separate features. We're also going to begin by checking the model to see what must be done before the shell and make sure we do those features first. We're also going to be looking for repetitions. There are 3 pattern features that we're going to want to include in this model. And lastly, dimensions in parentheses are reference dimensions and should not be used while modeling. So there are a decent number of reference dimensions here just to help with clarity. A majority of them are actually used on the primary or on the starter file. So consider yourselves lucky I didn't put you through that gauntlet. I figured last summer suffered enough there. All right. Yeah, so all in all, this should be kind of fun. Well, at the very least, not too hard, but there are a lot of pieces to it. So first up, taking a general look for the shell, we can see in section AA that a good chunk of the object is hollow. So we've got this solid bit up here. I think I've called it the emitter. I'm not a, well, I'm a big Star Wars fan, but I didn't look through the anatomy of a lightsaber before for prep for this. So we're going to call it an emitter. And then we have the handle and the hilt bits. So anyway, this part's solid, so we know that all of that stuff needs to happen after the shell feature. Looking at the hollow bit though, we can see on the inside that we can see the insides of those little rib bits. So these little rib fins at the bottom, those are going to need to happen before the shell feature. Otherwise, when we create them, they're going to be solid and we won't see any evidence on the inside. You can also see we've got this sort of rectangular panel sticking out of the hilt. And taking a look at section B, which cuts through that bit, we can see that that little rectangle is solid, so that will happen after the shell feature. So we know the rib and the pattern, creating the ribs, that needs to happen before the shell. We also see that we've got these sort of ribs, but like, I guess more circular cuts that we have going on the insulator, as I've called it. And those are also visible on the inside of the shell, so those will also need to happen before we create the shell feature. All right, so pretty much we want to do these ribs and the rib features and the ribbing on the insulator, and then we can create the shell and figure out what to do after that. I'm going to start with the ribs down at the bottom, and to make things a little easier to see and less cluttered, I'm also going to hide these dimensions. So we'll go to annotations, right click, and uncheck show feature dimensions. Cool. All right. So what do we know about these things? We have a detail view for detail E, which is giving us some dimensions for it. So it's a 15 unit long vertical line, and it's offset 10 units down, and it has these two diagonals at 130 degrees. We also, I believe that's actually it for the dimensions there. Looking at section C, where we can see a bit of a more clear perspective, we can also get a width of the rib and a depth of the rib. Oh yeah, we needed the 4 as well. So that 4 is going to tell us how far off this is from the surface of the cylinder. But all in all, we see it fairly clearly in the front view, so I'm going to open up a new sketch on the front plane, Control 8 to bring us normal to, and let's get a sketch in place. So using this, I believe that, well, technically, if we wanted to, we could leave the endpoints of a rib sketch undefined, so long as all of the rest of them are, but I personally prefer to fully define things whenever possible, so we're defining that as that. Now, to throw some numbers at it, we can tell that this top left corner is 10 units down from this sort of surface here. So we'll plug in that 10. We've got our 4 units from the edge to the side of the cylinder. 4 units there. We also have a 130-degree angle measuring between those two. And we are told that this overall bit has a height of 10 units. So that's almost fully defined. We just have this other little diagonal line. To me, let's cross out some of these. Use the 15, the 130, the 10, the 4. To me, this looks pretty similar from top to bottom. So I'm going to make the assumption that these two should be equal to one another, or symmetrical, effectively, but equal will pull that off for us. So that gives us a nice fully defined sketch. Now we can go back over to our Features tab, select the rib feature, and plug in our numbers. So we know it has a width of 10 units. We also want the little gray arrow pointing towards the rest of the object, so I'm going to flip our material side there. And we can also see that as it approaches the object, it expands. So we're going to want to turn on our draft and pop in 20. So you can choose either at sketch plane or at wall interface for the thickness of the rib. At sketch plane is the default for good reason. That's usually what you want to leave it as, but you could change it if you wanted to. And check mark. Cool. So that gives us our first one of these little nibbins. So we got one down, and we have 5 more to go. But instead of doing that manually, I'm just going to use a pattern. So we are on the Features tab. I'm going to hit the drop down below our linear pattern and select the circular pattern option. So for this, the thing that we want to pattern is the rib, and we want to pattern it about the central axis of our object. So for direction 1, I'm going to pick something that defines a central axis, or just one of the cylinders, and then we can bump up our number to 6 of them, because we can count all 6. Usually it's around 6 or 7 is the cutoff when I would just put an X6 or whatever, or a 6X. But in this case, that should be good. So we'll hit our check mark, and that gives us the other instances of our little nibbin. Cool. So we've used the 4, we've used the 10, we've used the 20 degrees. All right, next up we've got these sort of cuts in the insulator. So for this, we are given a closer view of them in detail F, which is based on the right view of the object. So for section A, we have a detail view based off a section view based off a multi-view. So tracing this back, we can see section A is cutting through what would effectively be the right plane of the object. So if we wanted to really be sticklers for it, we would create our new sketch on the right plane. Let's expand this a little bit so it matches up visually. However, you could also do this on the front plane because it's rotationally symmetrical. So regardless of which surface we sketch it on, we're going to hit Control 8 to bring us normal to, and then let's draw in our little triangle. So we can see that it's kind of based off of this edge. So I'll draw that there. And then we've got a little cut in like that. Another thing that's also handy with revolves is to get a center line in place. So we're going to go to our drop down next to the line tool, pick center line, and this is going to be revolved about the central axis of our object. And because the base object is set so that the central axis passes through the origin, I'm just going to create a center line that goes vertical from the origin. You don't technically need to do this, but it does maintain consistency for our standard feature stuff, so we're going to do it. And then we can use our smart dimension to define some numbers on this thing. So we can see that the triangle has a 100-degree angle, so we'll plug that in. You can also see that it is 4 units vertically aligned, so the height of this line is going to be 4 units. Very careful here. There's a difference between 4 units long and 4 units tall. It's a rather small difference because the angle here is pretty slight, but it is a difference. So we want to make sure that we are defining the vertical distance here. So we'll place that in. It's 4 units, so we'll plug in our 4 there. And we also have a 2-unit offset, telling us that the top corner of that triangle is 2 units down from the shoulder. So dimensioning from the shoulder to that point, plug in our 2, and that gets that bit mostly defined. We do still have an underdefined portion of our sketch though, so we need to figure out what to do with that. And in this case, that looks pretty equal on our picture. It's not incredibly clear exactly how big this triangle is, but I'm going to make the assumption that the two sides here are equal. So we'll hold down our Shift key and select them both, apply an equals relation, and everything here looks pretty similar to what we've got in the drawing. Cool. Cross out our 2 as well. Now we've got a fully defined sketch, so we can pop over to our Features tab, Revolve Cut, and check mark. So that's the first one down. Now we need 12 more. So for this one, I'm going to use the linear pattern feature. So once again, we are on the Features tab, linear pattern. And for this, we want to select the feature that we're patterning first. So we'll go to Features and Faces, select our feature, and then we can choose our direction. So if we were to just pattern this straight down, it would carve into the object and the cuts would no longer be visible on the outside. So we actually want it so as the cuts go down, they expand slightly. So pretty much what we want is the sketch that was used to create this to vary as it goes from one instance to the next. So in order for vary sketch to show up as an option, we need to pick a dimension as our direction. So double check pre-lab 9 if you are curious on the full explanation of vary sketch, but for now, the dimension that is going to be modified as it goes from one instance to the next is the 2. We want to flip it to the other side, and to actually see what it'll do, we want to set it to full preview. It'll polish out as we actually set it. Sometimes the preview takes a moment, but in general, that gets that set up for us. So let's see, what is the spacing from one to the next? 6. So we have a 6-unit spacing, and there are a total of 12. Oh, that's why it didn't update. If we check the very sketch box, there it goes. All right. Went through all of that buildup and I screwed it up anyway, but all right, cool. Yeah. Picked our direction. The direction was that dimension. Check very sketch. now the preview shows up correctly. And if we hit our check mark, we get all of the little carvings in. Nice. All right, so that wraps up. Let's see, wait a moment. Is that? Did I get a dimension wrong? Yes, I did. This should be 15. All right, there we go. I thought the ribs looked a little stubby. There we go. That looks better. Cool. All right. Those of you that caught that earlier and have been frustrated with me ever since, I hope that you can forgive me. All right, cool. So, if you use that 6, and if you use the proper 15, there it is. All right. So, that is everything that needed to happen before the shell feature. So, let's do the shell now. So, we'll pop into our shell. We can see that the shell has a thickness of 3 units. So, we'll type in our 3. And to actually see what this is going to do, I'm going to check the show preview. So now we can actually see what's happening. So based on the drawing, we don't actually have any surface that the shell is going to remove. The shell just hollows it all out and maintains the standard thickness throughout the entire object. So we don't actually need to select anything for our shell feature here. So we can just hit our check mark. And if we take a look at the section view of our object, using that button there, we can see into the inside to get a better perspective on what it is that we're dealing with. So this can be rather handy as a way to get a better look at what you're working on. And then you can just select the section view again to get you back to normal. All right. Excuse me. So that is everything that happens before the shell. And now that we are after the shell, we've got a couple more things to play with. I'm going to do the emitter next, I believe. So before we really get started with that, though, there's a couple of tricks that we're going to want to keep in mind. So the first one is the emitter here. It sort of has these diagonal edges, but when we take a look at problem 4, we want a version of this to be able to be made that does not have those diagonals. So it's just flat cylinder all the way around. So because of that, when we create our sketch for the emitter, we need it to be a base cylinder initially, and then sort of large, small, medium, small. And then we can add a chamfer feature afterwards that we would then be able to suppress or unsuppress to get the second configuration. The other thing I want to bring up is the little divot on the top of the emitter. So taking a look at this, you could, if we only had problem 3, you could either do this as part of the revolve, or you could do a separate revolve cut or extrude cut to carve in that little divot. However, because we also have problem 4 that we're dealing with, we need to be able to have a version of this part set up so that when the blade L is changed, as we can see on the table for the different configurations, when blade L is changed from 65 to 300, we want this depth to pop upwards. And with a standard extrude cut or revolve cut, there isn't a way to go from a negative feature to a positive feature within or without changing the feature type. So effectively what this all boils down to is we want to make sure that this little divot is included as part of the initial revolve. Otherwise, when we try to create that later, we won't be able to create the extended configuration. So, all that said and done, let's actually draw the dang thing. We can see it clearly in either the front view or the top view. So they're the front view or the right view. So we can effectively pick whichever primary plane we want that isn't the top. Done everything else in the front view so far. Or at least I've talked about doing everything else in the front view. Did I actually? No, I did that in the right view. We'll do it in the front view. So like the other revolves in the past, it is useful to create a center line. This is also going to let us get the dimensions in place, which will be handy. Then we can draw our profile. So it sort of starts with the sort of skinny cylinder, then it goes out, up, and back in, then another skinny cylinder, then we've got a wider cylinder that goes out, up, and over. Then it's going to dip down into the divot and then connect back to our center line. And to finalize this revolve sketch, we need to close the loop. So we'll bring that last line all the way back down to the bottom and connect it in there. Nice. All right. Based on our section view, we can see that both of these cylinders have the same diameters. So in order to set that up to play nice, effectively we want both of these lines to be collinear. So that means that if we were to lay a ruler along them, the ruler would contain both lines without either of them sort of going and jutting off to the one side or another. Now we can use our Smart Dimension tool, and this one's a doozy. So start our top, work our way down. We know that the top bit of our emitter is a diameter of 54, so dimensioning from a point to the center line, and then to get the diameter out of only half of it, we move the cursor to the other side. And that uses the double dimensioning trick that we've discussed in the Revolve Lab and several times since then. Cross out our 54, let's do the 38. So dimensioning from the point to the line, 38. We know that the height from the base of the dip to the start of this, so this distance here, we know that is 65. We know that from the top of the large cylinder to that shoulder, that distance is 29. So let's see, 38, 29, 65. We know that the smaller, thinner neck has a diameter of 15. So we'll plug in that. We know that the thicker portion has a diameter of 35. We also know, what else do we know? We know the thicker chunk has a height of 11. So got that there. We know that the distance from the bottom to that starter ring is 13. So cross out 13, cross out the 11. And we know the distance from the top of that ring to the bottom of the larger cylinder is 16. Cool. So that was a bit of a gauntlet as far as trying to get all of the little definitions in place, but they are all there now and we're fully defined. So we can pop over to our Features tab, Revolve Boss Base, check mark. Now if we hit Control 7, it should look like what we are trying to get it to look like, which is always a positive. Alrighty, let's do the chamfer next so that we don't forget it. So for that, I'm going to hit the drop down next to the fillet feature. We can go to chamfer. And for this, we see that it's inset by 12 and it has a 60-degree angle. So we'll plug in our 12 there and our 60 degrees there. And we can click our edge. And importantly, we want to make sure that it is measuring this correctly. So here it's going 12 units up and then measuring 60 from the vertical, which is not what we see here. So we're going to need to flip it so that now it is measuring 12 units along the radii and then measuring the 60 degrees with respect to the horizontal. Check mark. Cool. So we can cross out our 60, cross out the 12. Let's see, what next? I see a couple of rounded edges throughout our model. In particular, down at the bottom, we have a dimension, come on, there we go, a 4x R2. So that tells us that there are 4 sort of fillets going on throughout this object. So 3 of them are fairly easy to spot. We've got sort of rounded there and rounded there. And we also see that we've got a rounded bit in the divot at the top. So we'll plug in Z2 there for the radius. Bottom edge, top edge, and we get the inside of this. There we go. The 4th one's a little tricky. However, if we look closely, this kind of looks like it sort of expands outward a little bit. And if we take a look at detail D, we can also see that it seems a little rounded there as well. The real smoking gun, though, is if we take a look at section AA on problem 4. On the inside here, we can see that it is rounded. So it's not rounded on problem 3. We can see we have those nice sharp corners. But one of the steps that we're going to need to take when going from 3 to 4 is changing shell order with respect to a couple of features. So in order for it to be rounded in this bit, then we need it to also be rounded on the outside. And in order for it to be rounded on the outside, we need to have that fillet apply to the outside of our object, which is going to be right there. Check mark. Cool. So that is all 4x of our R2. Now, let's see what next. Let's do this little block that's coming out the side. So here is one of the first places where the actual orientation is really going to matter. With looking at our isometric, we can see that it kind of comes out over here. So to me, that seems like probably we would want a sketch on the front plane. As far as the feature goes, you could either do this as an extrude, sort of going top to bottom, and that would be drawn on something parallel to the top plane. Or the slightly easier option is we could do a rib on the front plane. So I'm going to open up a new sketch on our front plane there, grab our line tool, and dimensions sort of. So from the front view, we can see it looks like it goes all the way to the top of that cylinder, down to around there-ish, and to the edge there. So it looks like it's floating a little bit. Well, first, that is generally okay as far as rib sketches go, but also to clarify this, SolidWorks does not fully draw cylinders in reality. So if we take a look at it from the top, that's not a circle, that is a polygon. It is in reality a circle, but because there's rendering limits, and if you want SolidWorks to run smoothly, you need to set the settings a little low sometimes. It approximates it as a polygon. But in any case, that's the main sketch for the rib, but we do still need to define it a little bit more. You're allowed to leave endpoints underdefined, but the lines all need to be black. So for this, let's set the 25, which is going to specify the distance from the extent of the rib to the central axis. And since the central axis passes through the origin, we can just use that and plug in our 25. Now we'll go back over to our Features tab, activate our rib, and this we can see has a rib thickness of 20. So we'll plug in the 20 and check mark. Then we can do a Control 7, and that looks like what it's supposed to look like. Yay! All right, I think we have 2 features left. Well, 4 features, 2 things and 2 patterns. No, 3. 2 things in 1 pattern, because the holes for the hole wizard on the top and the vertical stripes are going to be controlled by the same pattern. And we know that because down in E for part 4, it says to decrease the instance count of the holes and the cuts in the hilt from 16 to 12. These should both be driven by the same pattern. You should only need to change one number. So using that information, we can then pretty much say, all right, so we're going to draw one cut, we're going to do one hole, and then we can use one circular pattern to get all of the others. Let's start with the hole wizard. So I need these holes cut on this top face here. So we're going to select that face. Then on features, we can go to hole wizard. And let's plug in our info. So we're told there's 16 of them. We're not going to use that piece of information just yet, but it is important to know. And they have a through hole diameter of 1 unit with a depth of 5. And we have a near side counter bore with a diameter of 3 units with a depth of 2. So in order to get this to play nice, we're going to need to set it to a counter bore. Reset, doesn't matter. And then we can plug in the info we need. So top, bottom, standard, we want to set this to ANSI metric since we're in millimeters. The type doesn't matter, the size doesn't matter, the fit doesn't matter. We do, however, need the show custom sizing so that we can actually plug in the sizes of our holes. So for this, we have the through hole diameter of 1 unit. We have the near side feature diameter of 3 units. The near side feature depth is 2 units. And the depth of the hole itself is 5 units. And that is controlled by the end condition, where we can change this from through all to blind. And then we can plug in our depth at 5. So now all we need to do is define a location. And for that, we can go over to the Positions tab, hit Control 8. Since I already selected the surface, it will bring me here, but otherwise you can select the face afterwards. And the one that I do know its location is this one up at the tippy top, where we are defined as 22 units out from the center. So dimensioning from the sketch point to our origin, we'll set that at 22. However, we are still underdefined, so if we click drag on this, we can see that it freely rotates, but we know it's all the way at the top, or we know it is vertically aligned with our origin because it lives on that extension line. So we'll select the point, select our origin, hold shift while doing that to get both, and apply a vertical. Cool. Cross out our 22, cross out our hole wizard, check mark, and that gives us one hole. All right, stripes next. So for this, we are pretty much going to want to create a sketch on pretty much any horizontal surface because we see it clearly in section CC, excuse me, which is parallel to the top plane. So guess if we pick this face here, that'll work as a sketch surface. So we're going to create a new sketch. Control 8 to bring us normal to. Actually, that's not very helpful right now. We'll draw it a little skew, I think. Let's do a rectangle. We use center point because it looks like it's going to end up being centered. And we know it has a width of 2 units. And we know that the inside of the cut is 17 units out from the central axis. So inside of the cut to, let's see, come on, origin. Let's do this the other way. We'll select our origin, select our smart dimension, select the point. Nope. Control 8. There we go. Now we've got our origin, and we can set that to 17. Oh, whoops, not the middle of it. My bad. We want the smart dimension to the edge. There we go, because that's what we see in the drawing. Y'all are getting all kinds of mistakes out of me today. So lastly, as I mentioned earlier, it looks pretty centered, so I'm going to use the center point from our center point rectangle and hold down shift to select our origin. Then we can apply a vertical relation. which gets us most of it, but we still have a little bit that we need to define, so we don't know the depth of this. So taking a look at our drawing, it appears as though that cut just pretty much goes through everything, but we don't really have a through all option here. So instead what I'm going to do is take that line, and since I know that it needs to go through the border of our cylinder, I'm going to select the edge of the cylinder and apply a tangent relation. So we end up with a really stubby little rectangle, and then we can go Features, Extrude Cut, and we want to carve from that bottom surface up to this surface here. So it's going to cut up until it hits that, and check mark. Not quite right though. So we can see this is actually stopping, so it isn't cutting through the fillet, which is what we want it to do. So instead of that, we're going to go back in, edit our sketch, select our tangent that we created earlier. I'm going to move this to instead be tangent with that circle. So we're going to pick the slightly larger circle that expands our sketch considerably. But now, when we exit our sketch, it should cut through the fillet, which is what we see in detail D. Cool. So we've got one cut, we've got one hole. Now let's pattern them. So we'll go over to our circular pattern. For the features and faces, I'm going to hit the drop down for the mini design tree. We can select one hole and our cut. Then we can pick the direction. So I'll pick our cylinder here, and that'll pattern them around that. And we need 16 of them. So we'll plug in 16 there and check mark. Control 7, double check our orientation. Looks pretty good. Cross out our dimensions. So we use the 17, we use the 16x2. I see no uncrossed out dimensions that aren't reference dimensions. Those are allowed to be left as is. So to double check our work, we already have our material, so we can go over to Evaluate, Mass Properties, 1105.31, 1105.31. Excellent. So at this point, we would save our model, and then we can move on to problem 4. I think I'm going to cut the recording here, though, and just start a new one. So back in a moment. See you on the next one.